In this lesson, we are talking about data distributions and their shapes. So there are three ways to describe the shape of a data distribution. The first description is that it is skewed. So skewed just means that it's offset to one side or the other. So we'll look at this first column here where we have this data distribution, and each of these data distributions has what we would call a tail on the right side, meaning that it has less data on the right side of the graph. Okay, so this data would be skewed right because it has less data on the right. Okay, that means that most of the data is on the left, and then it's offset by the little bit of data that it has on the right. So it has more data on the left side, and it's offset by the right side. So it's skewed right. Okay, so typically because it's offset by that right side data, that means that your median is going to be your best measure of center. Okay, now moving on to the next skew, we have these data distributions where the tail is on the left side. So when your tail's on the left side, we would say that that is skewed left because there's less data on the left. Okay, that means most of the data is on the right side, and it's offset by the data that has just a little bit on the left. So again, because this is offset by some outliers, some really high or really low values, then this is typically going to be best described with the median as the measure of center. Okay, up next we're going to talk about symmetrical. So this is the second way to describe a data distribution shape. So data that is symmetric can be two types of symmetric. It can be symmetric and bell-shaped, or it can be symmetric and U-shaped. So you can see here we have this one that's kind of bell-shaped, and then we have this one that's kind of U-shaped. Right, so when it's bell-shaped, so that's this one, it has most of the data in the middle of that distribution. Okay, so it has most of its data point in the center with symmetry on both sides. So symmetric, when it's bell-shaped, it just means that you can cut it in half and you have most of it here in the middle, and then it's symmetric here on these sides. Right, so with this one, because most of your data is here in the middle, your mean, or the average, is going to be your best measure of center. Okay, so that's for any bell-shaped distribution. Okay, then we have the symmetric, but this time it's U-shaped. So it's kind of the opposite of the bell shape. It's still symmetric on both sides, but this has the least amount of data in the middle, and it's still symmetric on each side. So it has its least amount of data points in the center. So in this case, because there really isn't a lot of data in the middle, your measure of center isn't going to do you much good. So neither the mean nor the median is going to be a good measure of center. So that's for any data distribution that has a U shape. And finally, the third way to describe the shape of a data distribution is uniform. So it's uniform if it has that rectangular shape, meaning that it has an even amount of data points for each measure that they have. So none of the measures of center are really going to do you any good here, because right in the middle, well, you have some data there, but then you also have a lot of data here on each end. So none of your measures of center are going to tell you much about the center of this data. So that's anytime you have this rectangular, straight across, even distribution. True or false? The data for the cars is symmetrical. So remember, symmetrical can either be bell-shaped, so it would look like this, or it can be U-shaped, where it would look like this. So, does this data look like either one of those? No. I would say that this definitely looks skewed, because we have this with the tail, and we have this one with the tail. Example 2. Describe the shape of Daniel's data and Sam's data. Okay, well, looking at this data, if I were to describe this shape, I would say that that's pretty symmetrical. This one's pretty bell-shaped, meaning I can see that this is symmetrical on each side. So that's for Daniel's. We would say that that is symmetrical and bell-shaped. And for Sam, I would say the same with his, because we can see that this is symmetric about right here on each side. And number 3, describe the shape of the data for Lucy's Steakhouse. So we're just looking at Lucy's here. So the box plot on the top, we have most of the data here on the left side and then towards the middle, and on the right side we have this, what we would call a tail, where you have the least amount of data on the right. So this is skewed, and since the tail is on the right, it is skewed right. So in example 4, describing the shape of this histogram. So this histogram, you can see we have most of the data on the right, and over on the left, down here, is where we have the least amount of data. So since this is our tail, this is going to be skewed in the direction of the tail, or where the least amount of data is, which is on the left.